All right, now we're going to add and subtract rational expressions. So adding and subtracting has a whole different set of rules. And one thing you have to remember that maybe it's been a while, remember that when you're adding fractions, the top number is counting how many of the bottom we have. So here there is 1/3, and here there's 2/3. So if I add them all together, here I have 1, here I have 2, altogether I have 3/3. So remember, this bottom number stays the same because the top is the one that changes. The top is counting. And then we reduce, and all is fun. So that's the basic idea. First thing we got to do with adding and subtracting is, if we subtract, we have to find our common denominator. Okay? Combine the like terms, and the bottom stays the same. Okay, and then we reduce if we can. So let's try it out. So this is an addition problem, so I do not need to subtract. Hopefully that's fairly obvious. Okay, so the bottom stays the same, so 2x squared. It's already the same, so that's great. It's already a common denominator. Now on the top, I combine my like terms. So x squared does not have a like term, so there's nothing to add it to. Then we have -5 and +5. Well, that's 0. And then the -4x. Okay, I just added those two fractions together. I know, it's exciting. Control yourselves. Now we reduce. So remember, with reducing, we just did that. We factor first. So take out that GCF. Nothing I can really do here. But I have 1x in the top, and I have 2 down here. Remember, this is like xx. So 1x cancels with 1 here. And we are left with x minus 4 on the top, and just plain old 2x on the bottom. I know, you're excited. Can't wait to get to the next one. All right, with subtraction. So the first step in subtraction, if you look on the top, is keep, change, change. Now you have to do that because it's a subtraction. So with this, remember, with subtraction, we add the opposite. So when we're adding, remember, we're only combining the tops. So the bottom, as I said before, stays the same. We're not distributing that negative through there. So here, we make sure we change the sign of both pieces. So it's more like this, where we have to distribute that negative through. So it would be 7y minus 3, and then minus y minus 15. Now we combine our like terms, so that is 6y minus 18. Okay, and that's y squared minus 9 still. Now we factor, and factor, and these get canceled out. 6 over y plus 3. Moving on. Okay, so when we're adding, we have to make sure we have a common denominator. So that's what we have to check for. But remember, this is a subtraction problem here. So the first thing we should do is do the subtraction. If I don't do it now, I forget, and it's a big fat mess. So I'm going to do it now. 4y plus 3 over 3y. These are not the same, so I can't really combine them. But I'm going to change this to a plus and change all the signs of these guys. So it's negative y minus 2 over y. So now, looking at these, we have to find a common denominator. Maybe it's obvious to you, maybe it isn't. Basically, what you have to look for are factors. So this guy is factored. This is a 3, and this is a y. Those are its factors. That's it. This one has a y. So this one does not have a 3. So that's what we do. We multiply by the missing factor. So we multiply the top and the bottom here by 3 because it doesn't have it. So I need to get a 3 down there, so I multiply. Now this is because this is 3 times y. So then combine our, do the math here. Distribute this 3 through, so it'd be negative 3y minus 6 over 3y. Now that the denominators are the same, we combine our like terms. and for some reason I wrote really large. So I'm going to combine the 4y and the negative 3y. That's just y or 1y, and then the 3 and then negative 6. That would be negative 3. So we're done. Remember, the top can't be reduced unless there's a y minus 3 somewhere, and there isn't. Okay, so here we're looking again. We want to get these fractions looking the same. So I want the denominators the same. This is y minus 4. This is 4 minus y. They are opposite factors. So opposite sign factors. So to take care of that, we multiply the top and the bottom by what's missing. Well, this one, all the signs need to change. You could have done it with either fraction, but I prefer leaving it like this. Okay, so this 16 would become negative, oh, that's a plus. The 16 would become negative 16, and the 4 would become a negative 4, and the negative y would become a positive y. Making these two exactly the same now. So combine the top, none of the like terms up there. So it's y squared minus 16 over y minus 4. We factor. Okay, now these y minus 4 and y minus 4 both exist. So we're just left with y plus 4 over 1, or just y plus 4. And finally, we have the awesomeness one of all awesome town. So first of all, this is a subtraction problem. So I'm going to make that 3 negative because otherwise I will forget. Now, these guys, we have to get them the same. The problem here is this is x plus 5, and this is x. What are their common factors? Now remember, factors are when two things multiply together. So you need to think about, can I multiply x by anything to get x plus 5? Think really hard. No, I can't. Okay, if I multiply this by 5, I get 5x, not x plus 5. So that's badness. So they don't have anything in common at all. So what we need to do is multiply them by what's missing. So this one doesn't have an x plus 5, and this one doesn't have an x. So these common denominators, it's the most complicated one, but you just multiply by the other guy. Plus, so it's negative 3x minus 15. I'm distributing this negative 3 through. And then I don't like to multiply my denominators because I'm going to have to factor it out anyway, so why bother? So combine my 6 and my negative 3. Right? And then here, factor out a 3. I'm left with x minus, ooh, too bad. That's too bad. So we factor and see if we can cross stuff out. We can't. This is one's a minus 5, one's a plus 5. Nothing we can do there. You can distribute those back through if you want, but it's unnecessary. You are done. Right? Yes. Have a wonderful day.